In this case, we're being asked to simplify some fractions. And there's really nothing very different going on here than what we looked at when we were doing all of our exponent examples where we had quotients. So we're very much going to be using our exponent rules here as well. So importantly, I'd like us to write it as single fractions, so we will have to do some multiplication in the third case. And in all cases, we're asked to simplify, which means it should be in lowest terms. So for this first example, we can look at each piece separately. We can look at the numbers separately from the single x's, separately from any of the brackets. I think the one that stands out to most people here is that they notice that there's an x plus 1 in the numerator and in the denominator. So those simplify. Both top and bottom can be divided by x plus 1. And then maybe the numbers stand out to you next. 12 over 24. Well, both are divisible by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. And maybe now we write an intermediate step. So far we have 1 times x squared times 1. So we have, at the moment, x squared left in the numerator, and we have a 2, an x, and an x plus 3 multiplied in the denominator. Are we done? Well, no. We have an x in the numerator and an x in the denominator. In fact, we have 2 in the numerator. Right? X squared is really x times x and a single 1 in the denominator, so we can cancel a single x from the top and the bottom. We're left with a single x, 1x in the numerator, and 2 times x plus 3 in the denominator. As an aside here, particularly if this 2 is missing, so let me write this in a different color. A what if? Particularly if this 2 is missing, we have something like x divided by x plus 3. I know it can be very tempting to cross out these x's. So if you cross out those x's, you might say, well, I end up with 1/3. Isn't that simpler? But the fact is that we can't do this. And the reason is that these don't really match. We don't have the same thing in the top and bottom because we cannot cancel terms. We can't cancel terms. We have to cancel factors. So in each case, we had factors here. We had 12 multiplied by x plus 1, and multiplied by x plus 3. And we had only factors in the numerator. So in both cases, we had one term in the numerator, one term in the denominator, and we were able to simplify. In the x over x plus 3 example, so I should put we cannot do this. In this example, we had one term in the numerator and 2 terms in the denominator, so we're unable to simplify this way. If you want to look at a numerical example to prove this to yourself, if you had 3 divided by 3 plus, let's say 2, what is the answer here? Well, you should say that's going to be 3 over 5, because you know, because of order of operations, that you need to add before you can do the division. And 3 plus 2 is 5, and that works out. But if you're tempted to cancel those 3's, you'd end up with 3 divided by 3. You'd end up erroneously with 1/2. And only one of those 2 can be correct. And here you should say, no, there's absolutely no way I can do that. I'm not allowed to cancel those 3's. Well, if you can't cancel the 3's here, you can't cancel the 3's in this example either. Okay. Let's go back to a real problem. We have 14 times x times 2x plus 3, but we have 3 of them this time. And in the denominator, we have 7x cubed times 2x plus 3 times x minus 1. We'll start with the numbers. Let's just work this one left to right. 14 divided by 7 is 2. 7 divided by 7 is 1. Or you can just think of it as 14 divided by 7 is 2, which means there's a 2 in the numerator. I have 1x in the numerator, 3 in the denominator, which means I can cancel 1 from the numerator, and 2 of them will be left behind when I cancel 1 from the denominator. I can take a 2x plus 3 from the top and a 2x plus 3 from the bottom, but because we had 3 originally in the numerator, I have 2x plus 3's left. Remember that this is 2x plus 3 cubed. So it's 2x plus 3 times 2x plus 3 times 2x plus 3. And the x minus 4 doesn't have a buddy, so x minus 4 ends up, or stays, in the denominator. We don't have a lot of intermediate steps that we need to write here. All right, so this is one of those situations that we saw in the numerical case where it is nice if we could simplify before we have to rewrite everything in this last example in a single fraction. I know, for example, that the 2 and the 16 are about to end up in the same fraction, but on opposite sides of the fraction line. So I'm going to simplify them before I multiply these two fractions. They're both divisible by 2. 2 divided by 2 is 1. 16 divided by 2 is 8. I can cancel a 4x plus 3 from the top and the bottom, right? 4x plus 3 squared divided by 4x plus 3 is simply 4x plus 3. 4x plus 3 divided by 4x plus 3 is 1. Doing it very formally here. And then finally, I have a single x in the numerator and 2 x's in the denominator. So I can get rid of the x in the numerator and get rid of one of the x's in the denominator. So right now I have 1 times 4x plus 3. So I have 4x plus 3 remaining in the numerator. And in the denominator, I have 1 times 8 times x. So I have 8x remaining. Once again, I can't cancel terms, so we cannot simplify the 4 and the 8 or the x and the x. And that is our final answer.